Separation is the spacing of aircraft to achieve their safe and orderly movement while in flight and while landing and taking off. Separation is maintained through the application of air traffic control procedures that keep aircraft separated by minimal longitudinal, lateral, and vertical distances. The object of air traffic control is to promote the safe, orderly, and expeditious flow of air traffic. Air traffic control achieves the separation of aircraft vertically by assigning different altitudes, longitudinally by providing an interval expressed in time or distance in miles between aircraft on the same converging or crossing courses, and laterally by assigning different flight paths or geographical locations where protected airspace does not overlap. Air traffic control can establish and maintain separation using either radar or non-radar procedures. Radar separation is the spacing of aircraft in accordance with established minima. The information is displayed on a radar screen and includes the location of the aircraft that have been identified, as well as altitude, speed, and other information. This information is displayed on the screen in what is called a data block. When the controller has informed the aircraft that it has been identified and that radar coverage will be provided, it is said that radar contact has been established. For radar separation, the spacing between aircraft is expressed in distance, whether in feet of altitude or in longitudinal or lateral miles. Radar minima for longitudinal and lateral separation are 5 miles of distance between aircraft at the same altitude. Non-radar separation is the spacing of aircraft in accordance with established non-radar minima when aircraft position information is derived from information on the flight progress strips. Lateral and longitudinal non-radar separation is maintained as distance or time. The distance or time minima vary depending on a number of factors, one of which is the type of equipment on board the aircraft. For example, aircraft on the same, converging, or crossing courses which are traveling at the same speed and altitude must be separated by 10 minutes, regardless of the distance. However, if these aircraft are both using distance measuring equipment, called DME, and/or area navigation equipment, commonly known as RNAV, the minimum separation is 20 nautical miles. This video presentation will focus on non-radar separation and procedures. This is a typical air traffic control workstation. It may be manned by a single controller or a team of controllers, depending on factors such as sector location and the amount of traffic. Once an aircraft has been identified and radar contact has been made, information about an aircraft and its location, and the locations of other aircraft in the area, is displayed on the radar scope. In addition, controllers rely on radio contact with the pilot, and also have flight progress strips that give them basic information about the aircraft and the flight. This information comes from the pilot's flight plan. Controllers receive flight progress strips prior to the aircraft entering their airspace. A typical flight strip contains identification information such as the aircraft call sign, the type of aircraft, and whether it is equipped with a transponder capable of providing altitude information. In addition, the strip provides the true airspeed filed by the pilot and the aircraft's ground speed. Also included is the flight level the aircraft is assigned. In this case, flight level 240, which is 24,000 feet. The flight strip also tells the controller where the flight is originating, the jet airway the aircraft will follow, where any change in direction will occur, and the aircraft's final destination. As the aircraft moves through the sector, the controller uses the flight progress strip to record information and to indicate any changes in routing, speed, altitude, and so forth. Arrows are printed on the strip to indicate whether the aircraft is departing or arriving, in which direction the aircraft is approaching and leaving a fix, and whether the aircraft is climbing or descending.
November 13 Delta, descend and maintain 12,000.
Advising.
USO 37, reduce speed to 250. Continental 50, cross Cedar Lake 10,000, 250 knots.
This is a picture of how controllers typically ensure the safe and orderly movement of air traffic using radar separation. However, there are situations in which aircraft are not under radar surveillance, and air traffic controllers must provide safe and orderly flight using non-radar separation. Non-radar separation is a set of rules used by controllers when they don't have radar contact with the aircraft. Let's look at a couple of situations in which non-radar separation rules would be applied. Non-radar separation may be used when a controller is providing clearance to aircraft taking off or landing at any airport. In this situation, non-radar separation rules would be used for the aircraft's departure. Then radar rules would be applied as soon as the aircraft was under radar contact. Under these conditions, the period of non-radar separation might be brief. Also, non-radar rules are used in some areas of the country where the terrain interferes with coverage so that radar contact is not possible until aircraft reach a relatively high altitude. These situations may require the controller to use non-radar separation rules for an extended period of time. In addition, there may be other situations in which controllers use non-radar rules because radar contact with the aircraft does not exist. When using non-radar rules to keep track of aircraft and to ensure that they are safely separated, controllers rely on radio contact with the pilot and flight plan information printed on the flight progress strips. During the time non-radar rules are being used, controllers do not have radar to help them keep track of the aircraft. They form a mental picture of the locations of the aircraft and keep track of their movement by entering the pilot's estimated fix time and actual progress time over the fix and any changes in route, speed, and altitude on flight progress strips. While doing this, the controllers apply non-radar separation minima in order to maintain a safe, orderly, and expeditious flow of air traffic. Now let's look at some general information on those non-radar separation rules. Separation is achieved and maintained by spacing aircraft in distances measured either vertically, laterally, or longitudinally, or by a combination of vertical and lateral or vertical and longitudinal separation. Vertical separation describes the distance between aircraft above or below each other and is achieved by assigning different altitudes. Non-radar altitude assignments are made only after an aircraft previously at that altitude has reported leaving the altitude. Lateral separation is the spacing of aircraft flying the same altitude by assigning different routes or geographical locations where protected airspace does not overlap. The factors an air traffic controller must consider when maintaining lateral separation include the distance between aircraft when flying converging or diverging radials, the minima along airways or routes, and the amount of space needed for turns. Longitudinal separation describes the spacing of aircraft flying at the same altitude when on the same, converging, or crossing courses. When maintaining longitudinal separation, the controller must consider the speed and direction of the aircraft, the type of equipment on board, and whether the aircraft are climbing or descending. Vertical, lateral, and longitudinal separation procedures are used to achieve and maintain separation. Controllers select the most appropriate type of separation for the situation. For example, if lateral or longitudinal separation cannot be achieved, vertical separation is used to obtain required spacing. Non-radar rules regulating vertical, longitudinal, and lateral separation are applied in a variety of circumstances in order to achieve and maintain the separation of aircraft in flight and while landing and taking off. Air traffic controllers specify speed, altitude, and geographic position to maintain orderly sequencing of aircraft en route. And separation rules are also applied to aircraft during approach and departure. Let's look at non-radar regulations related to the initial separation of successively departing aircraft. In this case, separation rules specifically deal with aircraft on courses diverging 45 degrees or more, and aircraft departing on the same course. Diverging courses may occur from the same runway or from adjacent airports. An important factor for controllers to consider in the separation of successively departing aircraft flying diverging courses is the distance the aircraft travel after takeoff before the courses diverge. The significant factor for separation of aircraft flying the same course is whether the following aircraft will climb through the altitude assigned to the leading aircraft. If so, the controller must ensure proper lateral or longitudinal spacing, since the two aircraft will temporarily share the same altitude. When ensuring separation, the controller must take into account the speed of the two aircraft. During approach, aircraft are handed from the en route controller to the approach controller, then to the tower controller, who issues the final clearance. Handoffs between controllers are made at designated points spelled out in letters of agreement between different air traffic control facilities. In addition to separating successive departures and successive arrivals, controllers also maintain separation between simultaneous departures and arrivals. Separation minima are affected by takeoff direction and whether the departing aircraft will fly a course that diverges by 45 degrees or more. Holding aircraft is an air traffic control procedure used to achieve safe spacing, to allow aircraft to wait for accommodations at an airport, or to comply with traffic management requirements necessitated by traffic congestion, weather conditions, or other conditions. When holding traffic, controllers must be concerned with separation as the aircraft enter, fly, and leave the holding pattern. Controller responsibilities when holding traffic include clearing the aircraft to and from the holding fix, providing information updates about the hold and related delays, maintaining separation between all aircraft entering the holding pattern, protecting the holding pattern airspace, and providing separation for aircraft as they leave the holding pattern. Let's review. Separation is the spacing of aircraft to achieve safe, orderly, and expeditious flow of air traffic. It is the objective of air traffic control to achieve and maintain separation using radar and non-radar procedures. Radar procedures rely on information from the radar screen and flight strips to safely space aircraft when in flight or during arrivals and departures. Non-radar procedures rely on radio contact with the pilot and the use of flight strips to achieve separation. Both radar and non-radar rules provide separation vertically by assigning different altitudes, longitudinally by providing an interval expressed in time or distance, and laterally by assigning different flight paths or geographical locations where protected airspace does not overlap.